Hello, so today we are doing this problem called longest turbulent subarray. So the problem says that we have this array, A, and an array is said to be turbulent, or a subarray of the array is said to be turbulent. And so notice the subarray is from I to j. We say that it's turbulent if and only if for every index between I and j. Let's say k, so ak is bigger than ak plus 1 when it's odd, when k is odd, and it's less than the next element when it's even, or the other way around, which is k is bigger than the next element when it's even and is less than the next element when it's odd. So essentially it's a subarray where the element goes from less, the bigger one, and then to one that is less than that, and then to one that is, so it basically alternates between less and bigger, and it can be either that less starts out first, or bigger starts out first. So that's essentially the gist of this. And so basically what they are saying here is that the comparison sign flips between each adjacent pair of elements in the subarray, and the goal here is to return the length of a maximum size turbulent subarray. So maximum size turbulent subarray, that's what we want. So if we look at this array, for example, we can see that the first element, A1, is bigger than A2, is less than A3, is bigger than A4, and then is less. So you can see the sign goes from bigger to less to bigger to less. So it alternates like that. And the biggest one we can find is this one, of length 5. For this one, the biggest one we can find is 12, between 12 and 16, or you could take between 8 and 12, or 4 and 8. So basically, essentially, if an array is of size 1, it has to be just one element. There is nothing to check. If the array is of length bigger than 1 and they are not equal, then it has to be 2, because at least you have one of them is less than the other one, or one of them is bigger than the other one. And so that's essentially the problem. So let's think about how we can solve it. So one thing we can think of is we can just keep track. So we know we want the length of the maximum subarray, right? So just go through the array and keep track of the current length of the current turbulent subarray, right? And once when it no longer has turbulent, let's call them turbulence properties, then we can just set current length to 1, because at least if it has one element, then that's 1. So at least it has one element, and then that's just the value that we set here. Otherwise, you just keep increasing with whatever value we think is appropriate. So let's see how can we do this. So we need to have max length, and we need to have current length, right? And this one is, they starts out as 0 both, and then we need to go through the array, right? And we need to so this is range of length. So let's handle multiple cases. So one case is when we got more than 2 elements. So we said when we have 2 elements, we know the answer has to be 2. And so when we have more or equal to 2 elements and something else maybe, and when we have when we know it's at least bigger than 1 element, and then we have something else. So okay, let me just maybe not do this. So if it's bigger than 2, then we can check actually. So the what can we have for a turbulent subarray? We can have, according to this, we can have either ak is so if I take ak minus 2 like this, so for k bigger than or equal to 2, I can have either this, and then this way. So this one is like this one goes from less, and then goes up, and then goes down. So this one is like let's call it a peak, right? The other option is we can have that it starts out as bigger, and then goes down, and then it goes up again, right? And so this one is kind of a valley, right? If we draw it out, it looks like a valley, right? So we can have only these 2 cases for a turbulent subarray. So these are like turbulent subarray cases. And so we can literally just check this, because if it's like this, that's not valid, and if it's like this also, that's not valid either. And we can't determine that it's valid just from looking at this, right? The other case is if it's if k is like bigger than 1, and even if in that case, in that case we don't need to check the entire thing, because in that case all we need to know is that these are different, right? Because if these are different, that means that we have something maybe like this, or maybe we have something like this. So at least we have length 2, because at least we have this property. We don't need to check the rest of the property here. So that, for example, if we have an array like that has just these 2, we should return 2 for this array, because this one is still kind of turbulent, because there is no way for it to have more and have more comparison signs, right? And so, but there is another case where we have this one, and this one is definitely not turbulent because they are equal, and here the properties say we don't support equal. So in this case, it's not 0 though, because there is one element, and that one element is still valid. So in this case, the current length becomes 1, and in this case, the current length should become 2, right? And so what we need to do is check here. Let's call this k. So do exactly what we said here. So if, right, or we have the valid case. In all of these, what should happen? We should increase our current length by just 1, because this is just increasing by this ak. These we would have already explored them, and so we just need to say, okay, our current length now has increased by 1, and we need to check for the second case, this one. So this was our first case, this is our second case, and this is our last case. So for this one, it has to be at least bigger or equal to 1 so that we can check this, right? And so we can check and different, then in that case we need to, so it's not this, so we need to reinitialize our current length to be 2, because if it was this property, it would have already entered here and continue it, right? So we need to initialize it to 2. Otherwise, that means that they are equal. In that case, we need to initialize it to 1. And at the end, we need to, before doing this, we need to update the max length with the new current length. And we need to return that max length. So I need to change my k here to be a lowercase k, and here, okay, that should do it. Okay, so let's try a complicated case, a case that has like something like 0, 1, 0. So this one, it has length 3 because it's less and then it's bigger, right? So that one is correct. Let's try another one that has like 0, 1, 1, 0, 1, 0, 1, 1. So basically this one is a little bit more complicated because it has equal values here, right? It has equal values here and equal values here. So let's see this one. Okay, so I think this should work. Let's try with just one element. So let's try with this. Okay, so we have a problem here. We have an index out of range for when it's just one element. Let's see. So we said that k is bigger or equal to 2, so it shouldn't enter here, right? Actually I should say and this or that. Yeah. So basically the problem is it's like I'm doing an or outside of, yeah, so it's the parentheses problem, I think. Yeah, that was it. Okay, so let's submit this. Okay, so that passes. So this essentially is just a no-event solution, and we are just comparing with different cases, right? There is another way to solve this problem using dynamic programming, which is very straightforward. So let's try it out. So let's see how can we do that. So we can just have a DP state that is I and K, and let's call this C. And so I is so basically, and consider that this is like the length of the turbulent subarray ending at I, such that and C represents 0. C is equal to 0 if the subarray turbulent if subarray is ending with less, and it's equal to 1 if the subarray is ending with bigger. They're equal. So basically, ending with this means for me that AI minus 1 is less than AI A of I, and bigger means this. And so this is our DP state. It's a little bit complicated, but just the length of the turbulent subarray ending at I, if for the value for DP0, it's let's call it DP0. Make this clear maybe. So for DP0, DPI0 at this point, it's something, and then for DPI1 is something else. And so the state for DPI0 is that the length of subarray ending at I with such that AI minus 1 is less than AI plus 1. Is less than AI, sorry. And for 1, the length of turbulent subarray ending at I such that AI minus 1 is bigger than AI, right? And so if AI minus 1 is so basically, how can we so now we know our case, we know our recurrence or our DP state. So this is our DP state. Now how can we determine the recurrence relation? So the recurrence relation, of course, depends on whether AI minus 1 is less than AI or not. So if AI minus 1 is less than AI, so that means that we are in this state here, right? So that means that we need to calculate this. And so this one is, so since we are after a turbulent subarray, if this one is less, the previous one has to be bigger, right? And for bigger, that means it's 1, right? So it has to be 1 plus 1, because for this to happen and for it to be turbulent, we have to have less, but before the less, we have to have bigger. And bigger is represented by I minus 1, 1, right? That's the previous state, such that the element before that was bigger than the element I minus 1. And so it's I minus 1 here. Otherwise, if it's bigger, then it's a similar case, but this time we would have the recurrence relation is, since it's bigger, the DP state now is for 1, right? The previous one we don't touch that. We leave it at 0. We'll leave it to the default value, which is yeah. So yeah, I will come back to that. So the default value shouldn't be 0. So we need to initialize all DP states to 1 because of this case that I mentioned here, that for all arrays for every subarray of length 1, the DP state is 1. And so we need to initialize all DP states to 1 first, so that if we don't set here DPI1, it's 1 by default. It's already initialized to 1, because if we have something like this, then that means that the DP state is the current length of the of the turbulent subarray ending at I is 1, right? And so here it would be 0, because if we have this sign here bigger, then the previous sign has to be less. And this sign here ending at I minus 1, that's this here, that's dpi minus 1, 0 plus 1, right? And so after that we can just get the max of that state of both and just return it, right? So let's write this out. So dp, we need to initialize it, we said to something with the value 1, right? So 1 for in range of length of length of A, but we also need to have it with 0 and 1 states, right? So this is actually range 2, and this is range of length of A, so that we can have dpi 0 and dpi 1, right? So let's just make sure of this, and so let's just set A to be, I don't know, 0, 1, 1, 1, right? And then let's see what this gives us. So yeah, it gives us values for each of these states. We have 2, 1 for 0, 1 for 1, so that's good. Now what do we need to do next? Next we need to just go through the length of the array and update our state and do the recurrence relation, right? So our recurrence relation would be something like this. And after that we need to update our max length. Let's call it here max length. Let's initialize it. It starts out as let's say it starts out as what should it be? So let's say it should start as 1 if so let's say min of 1 and length of A, so that if A is 0 we can get max length to be 0. And so max length is going to be equal to the max of max length and either one of these two. It's one of them, right? It's whichever is maximum with the previous maximum, right? So that would be this, and we can just return max length. Okay, let's try with this case. Okay, and then let's try with this one. Okay, so this one doesn't work correctly, so we have a mistake somewhere. Where did we make the mistake? Okay, let me just try to initialize this to just 1. Okay, so that's not the problem. Yep, so actually our I here, if it starts as 0, we are going to have problems because this would be -1, and in Python if we do A -1, it's going to go to the end value, right? And so we need to start from 1 so that this I -1 works. And we already set the max length to the minimum of 1 and the length, so if it's just one element, we'll have the right solution. Yep, so that was it. And let's submit. And that passes. So that's all for this solution. Yeah, see you next time. Bye.